All right, let's move on to number 2, where we are going to be calculating, we're going to be finding the absolute max and absolute min for f of x equals x squared plus 2x plus 1 on the interval -3 to 2. All right, so remember what you've got to do there. You always need to include the endpoints of the interval. You need to check at the end, -3 and at 2. And then we also need to find any values where there's critical values in between. So there could be a high or a low that could take us below or above where the endpoints take us. So the idea is we need to find the critical values and then the endpoints and check all of those that show up. So we need to first find the critical values. F prime of x then is equal to 2x plus 2. That equals 2 times x plus 1. So we set that equal to 0 to find the critical values. So we've got 2 times x plus 1. The 2 has no influence on whether it makes it 0 or not. That x plus 1 is the entire issue. So we end up with x equals -1. So is that in the interval from -3 to 2? Yes, it is. So what we need to do is calculate. We want to find out what the maximum value of the function is at the endpoints and at x equals -1. So we need f of -3, f of -1, and f of 2. Calculate the values of each of these. The biggest one will be the absolute max, and the smallest will be the absolute min. So we end up with -3 squared plus 2 times -3 plus 1, 9 minus 6 plus 1, 10 minus 6 equals 4. Then we've got f of -1. We end up with, that's +1, that's -1 squared plus 2 times -1 plus 1, which is 1 minus 2 plus 1, which is 0. And for the last one, f of 2, we've got 2 squared plus 2 times 2 plus 1. That ends up being, we've got 4 plus 4 plus 1 equals 9. So we've got the points -3, 4. We've got -1, 0, and 2, 9. Notice what the largest value of the y value is. The 9 is going to be the max. And the min is going to be at 0. So the answer to the question, absolute max is 9 at x equals 2. Absolute min is 0 at x equals -1. All right, let's move on to number 3. All right, so now we've got number 3 from quiz 6. Let's go to the iPad. And the problem is, the gist of the problem is that there's 180 feet of fencing you've got. The rectangular region is up against the river. And as a result, you've only got 3 sides of a rectangular region that you're concerned about. The question is, what's the maximum area possible? And most commonly, people pick, when solving this problem, recognize that you need 2 equations when you do these optimization problems. 2 equations. One is an equation for the amount of fencing you have, and then a second to determine the thing you've got to maximize is the area. So you need an equation for the feet of fencing, which is the rectangular, the perimeter around that area, and the area for itself. So if we recognize that there are 2 sides that are the same, and we only need one of the other sides because of the fact that it's up against the river, like in the drawing there, then we can see that the amount of fencing we're going to be needing is equal to the 2 x's added together plus the y. And you're told that that's 180 feet is what you've got to work with. So in these optimization problems, remember that one of the equations you're going to be given the information for. The other one, you need to optimize, either maximize or minimize. So the second equation that we've got to work with is the area. We've got to maximize the area. And for this rectangle, you can see the area is length times width, which in our case is x times y. So as a result, now the idea is solve for one of the variables over in the other equation where you've given a value, told them that there's 180 feet. Solve for y. We end up with y equals, subtract the 2x, we get 180 minus 2x. And now if I bring that y over to the other equation, I can get a in terms of just the letter x by substituting in this for the y. I end up with x times 180 minus 2x. That means area then is equal to 180x minus 2x squared. So I have a function of the area. I'm trying to maximize the area. So I'm going to take the derivative of this equation for the area, set it equal to 0, and solve for x, and then answer the question. So take the derivative, a prime equals 180 minus 4x. Everybody comfortable with that? All right, bring the 2 down, multiply by the 2, you got the 4x. And now set that equal to 0. I've got 180 minus 4x equals 0, 4x equals 180. X equals 180 over 4, which turns out to be 45. So I've got x equals 45. That doesn't answer the question. I need the maximum area. So I go back, plug the 45 back into my equation for y, and I've got y equals 180 minus 2 times 45, which is 180 minus 90, which is 90. Therefore, the place where the maximum area occurs is going to be where x is 45 and where y is equal to 90. Therefore, the area equals equal to 45 times 90, and that turns out to be 4050. You got to make sure you're solid on this. This is area now. Area is in square units. So the final answer is max area is equal to 4050. We're talking feet. So this is feet squared. Go back to the final, go back to the question and make sure you answer the question. All right, that takes care of number 3 for quiz 6. Hope it clarifies it for you.